I will share the information about two major things if you run a programming house you really have to avoid. Number one is that you program run code to a device. You can understand that if you program a run code, okay, and this chip is soldered on the PCB and put into a product, then that is a nightmare. Sometimes the PCB itself, the whole PCB cannot be used anymore. Number two is that you have to avoid IC stacking. That means you place the chip in the sockets, okay, and you did not take out the first chip, but you place the second chip on the top of the first chip, and you keep programming the first chip, but the second chip is always taken out. That means the empty chip will always go out to the field. So I will be talking about how to avoid these two major risks. Number one is that in order to avoid programming run code, you have to implement first article. First article means that it's a document or it's a project file, include all the necessary file configuration or option byte or requirements from your customer. And this first article file cannot be changed during the whole production process or after the production process. So this is to avoid that your operator or your engineer use the right code but select the wrong option byte, or use the right code but select the wrong configuration. So even you have the same file but wrong option byte, the programmed chip still cannot be used on the PCBA. So you have to use the first article. Number two is that once you have implemented first article, you have the project file to program a batch of chips. But if your factory, you are programming many customer projects, you let your operator or engineer manually select a project file. Sometimes can make mistakes because operator may select the wrong project. It's better to use a barcode to scan the project you are going to program. So this is to avoid that human error during the production process. So DediProg, we provide the customer with all the necessary API and the library so that the customer can integrate into their process and use the necessary barcode or MES to streamline the process. So number two, I want to mention that the IC stacking. First of all, why the machine can cause such problem? Typically, there are two possibilities. Number one is that operator make mistakes. Once the chip is not taken out from the sockets, typically machine will detect and will stop. But if the operator does the error handling not correctly, for example, delete the machine error code and let the machine continue to run, or they just did not see there's a chip inside and let the machine continue to run. Number two is that the machine itself did not detect the chip, didn't take out from the sockets. Sometimes if the vacuum gauge is malfunction, then maybe the machine does not detect the chip, or the nozzle is clogged. There's a lot of dirt inside the nozzle, so the nozzle does not deliver correct pressure to the sensor, and then the machine does not stop. So these are two possibilities causing IC stacking. So the way to avoid IC stacking, there are actually multiple methods. So typically, DediProg, we do not rely on a single method. Number one, you have camera to check whether there's a chip inside the sockets. There's an electrical checker mechanism. So the programmer itself will try to detect whether there's a chip inside the socket before the chip is placed into the sockets. So this is the second mechanism. Number three is that use a laser to detect whether the height is different. So once if there's a chip inside the socket, the height is different, then the socket is empty. The last one is that the chip stacking can be supported by the software, by algorithm. So for example, once the chip is placed in the socket, the programmer can try to read out the chip first before it is programmed. And then we will use this readout data to check whether the readout data is equivalent to the data we are supposed to program. So, and this is the way we understand whether that chip is already stacked or is a new chip. So this is what I want to share today. Thank you.